Hello, good people. Let's take a look at 7/6 inverse of a square matrix. I've got some writing on here. I was using this earlier. I'm just going to go with it. First off, when we've worked with just numbers, you've learned about inverse properties. For instance, 6 minus 6 equals 0. 6, or 6 better yet, plus negative 6 equals 0. Negative 6 is referred to as the additive inverse of 6. When we're talking about inverses with square matrices, we are talking about multiplicative inverses. And 7 is the multiplicative inverse of 1/7 or vice versa because they multiply to be 1. Now, worth noting, 1 in a 2 by 2 matrix land is 1, 0, 0, 1, and in 3 by 3 it's 1, 0, 0, 0, 1, 0, 0, 0, 1, which we should be comfortable with because we understand that's kind of the form a matrix takes when we use row reduced echelon form. We want those ones down that main diagonal and all other zeros. Why does that work? Let's take a look at this matrix. 2, 3, 4, 5. Nothing special about those numbers. If I multiply that by 1, 0, 0, 1, we get 2 times 1, 2, 3 times 0, 0, 2 and 0, 2. And when I take the first row times the second column, I get 0 and 3. Second row, first column, the 4 survives, but 5 gets wiped out. 4 plus 5, 4. And 4 times second row, second column, 4 times 0, 0. 5 times 1, 5. 0 plus 5, 5. So that's our, this is 1 in 2 by 2 land. Okay, so in this case, if I had two matrices that multiplied to be 1, if this was referred to as A, we would call this one A inverse. And multiplication of matrices it's not commutative, but if A times A inverse gives you 1, 0, 0, 1, then or if matrix A times matrix B, let's say, gives you this, then it is matrix B times matrix A will also give you that. So anyway, there's a lot going on here. Worth noting, matrices potentially have inverses if they're square, and we'll find out not even all square matrices excuse me, have inverses. Okay, now the process for finding an inverse matrix. There's a specialized process for finding 2 by 2 matrices down here. I don't even use it. I suppose if I lived in an environment where I was working with 2 by 2 matrices all the time and needed to find their inverses all the time, then maybe I would bother to memorize this. But memorizing this, I think, is a scary proposition, easy to mix things around. So I don't use it. I use this process, and basically what they're telling us to do is if we have a square matrix, augment it with the identity matrix, which is that 1, 1, 0, 0, 1, 1 in 2 by 2 land, go through the Gauss-Jordan process, and when you're done, and get this to look like, get the left side to look like 1, 0, 0, 1. The right side will then be your inverse. And to reinforce that, I want to go straight to an example problem like that, which on the next page would be number 12. Find the inverse matrix if it exists. So we would take 1, 2, 3, 7, augment it with 1, 0, 0, 1, and go through the Gauss-Jordan process. Multiply this row by -3. I'll tell you, we ought to be experts at this but by the time this chapter's over, the Gauss-Jordan process. Hitman row that I refer to, 1, 2, 1, 0, doesn't change. Touch, -3 and 3, 0. -6 and 7, 1. That's a blessing right there. -3 and 0, -3, 0, and 1, 1. New Hitman, multiply that row by -2, send it up, and we get touching 0 and 1, -2 and 2, +6 and 1, -2 and 0. And the right side became row reduced echelon form right here, or that's our identity That's 1 in 2 by 2 land. If let's say this was 6 here, I'd divide this row by 6, just like our normal Gauss-Jordan. So if we refer to this matrix as A, its inverse is 7, negative 2, negative 3, 1. Okay? So that's the process. Now, how do we show that matrices are inverses? Well, how do we know that 7 and 1/7 are multiplicative inverses? Because they multiply to be 1. So I want to see what these matrices multiply to be. So once again, what I refer to as the spinny finger thing. First row, first column, I get negative 8 plus 9, 1. First row, second column, I get negative 12 plus 12, 0. Here, second row, first column, I get 6 and negative 6. Second row, second column, I get 9 and negative 8. And sure enough, they're inverses. Now, for number 10, we could do this. We could distribute 1/4 to each of these, and then we could do first row, first column, first row, second column, first row, third column, dot, 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 and we would ultimately, hopefully, get to 1, 0, 0, 0, 1, 0, 0, 0, 1. But on the 3 by 3 here, I'm going to go ahead and allow you to use calculator because that's a skill as well. And so if problem number 9 is a 3 by 3 in the homework set, you may do this with your calculator. Let's go into matrix. I'm going to edit matrix A, and I'm going to make that be a 3 by 3. And I'm going to put in, maybe it's, nope, it's not there. Negative 4, 1, 5, negative 1, 2, 4. 0, negative 1, negative 1. I'm going to double check and make sure that maps up with A here. And that looks good. So I'm going to quit. I'm going to go back into matrix. I'm going to edit matrix B. And matrix B, actually, I already have that one in, as you can see. So that's a match. I did not include the 1/4 in there. You could distribute the 1/4 into each of these, but I'm just going to multiply the 1/4. I'm just going to multiply all of this times matrix A. So second quit. I want matrix A, and I want that times, and I want to show you this. We're going to get an error here, and I'm going to explain why. If I go 1/4 times matrix B, I believe this is going to give me an error. Yes. And the reason for that is the calculator is taking matrix A times 1, and it has no difficulty with that. But then we're supposed to take matrix A and divide by 4. Division is not defined in matrix land. So we would have to actually enter this as matrix A times quantity 1/4, or you could go A times 0.25, but it doesn't like the division. We can do this division. Now we enter there, and sure enough, we get 1, 0, 0, 0, 1, 0, 0, 0, 1, 3 by 3 matrix's version of 1. So what I would have you do on like number 9, if it's a 3 by 3, maybe 7 is as well, maybe 11, is just say, I guess there wouldn't be an 11, but anyway, just say went to calculator, dot, 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 got 1, 0, 0, 0, 1, 0, 0, 0, 1. But practice with your calculator on this. If it's 2 by 2 in your homework assignment, I'm expecting you to go ahead and work it out by hand. Okay, so back to this section, find the inverse matrix. Inverse, I'm going to refer you back to this page. Square matrix, and I mentioned that we have to have square matrices to get inverses. So inverse does not exist. 20 is going to be a little bit messy, but I'm going to go through that process. It's good practice for us for our Gauss-Jordan. 34025510000100001. So Gauss-Jordan elimination, good practice. On your test, you're going to have to do this once, but it won't be for an inverse. It'll just be solving a system of equations. Going to multiply by -3, send into row 2. Hitman row does not change. It stays 1, 6, 10, 1, 0, 0. -3 touching N3, 0. Touch them. -18 and 4. -14, yikes. -30 and 0, -30. -3 and 0, double yikes, because -14 and -3 are relatively prime. I'm not going to be able to reduce the row. Okay, we're going to, actually you shouldn't do that on these problems probably anyway until the very, very end. 0 and 1, 1, 0 and 0, 0. I'm going to multiply first row by -2, send it down. And I get -2 and 2, 0. -12 and 5, -7. I get -20 and 5, -15. I get -2 and 0. I get 0 and 0. I get 0 and 1. And now I'm going to use, because I can't reduce this, I'm going to use the 14 to whack the 6, and they match up at 42. So I need to multiply this row by 7 to get positive 42, this row by 3 to get negative 42, and go pay a visit to row 1. Touch them. 7 and 0. 42, and sometimes I might write off to the side here, but I think this is going to work out okay. 42 and negative 42. Well, we knew that was going to happen. 70 and negative 90. 70 minus 90, negative 20. 7 and minus 9, negative 2. 0 and 3, 3, 0 and 0, 0. Hitman row does not change. I'm going to multiply this row by -2, leave this row the same, and go down and pay him a visit. 0 and 0. -14 and positive 14. That's why we're doing it. Okay, let's see. I get -30 and positive 30, bonus 0. I get -3 and positive 4. I get 1 and 0. I get 0 and -2. Now, if this happens, I don't care what's going on over here, but if we get 0, 0, 0 here, that is an indication that the inverse does not exist. Otherwise, we're going to have a value here, and we're going to use it to whack those guys and end up dividing down our row, and we've got our inverse. But there's the process. Okay, and calculator. Use your calculator to find the inverse if it exists on second matrix. We'll zoom in a little bit here. We need too much room. And I'm going to edit A. It's 3 by 3 already, so we'll go with that. Second matrix. Edit A. And 3 by 3. And I'm going to enter this as -5 divided by 6, as you can see. 1 divided by 3. 11 divided by 6. 0. 2 divided by 3. 2. 1. -1 divided by 2. And -5 divided by 2. And then to get an inverse on my calculator for matrix, I'm going to quit out of here. I'm going to go to matrix. I'm going to call on that A matrix. And then you could check, and people may want to look here. They may want to go back into matrix math and see, do we have an inverse in there feature for it? We don't. So I'm just going to hit out of there and whoops, second clear, start this over. Second matrix A. Well, conveniently, the matrix button, this is inverse, like sine inverse, cosine inverse, tangent inverse. This is flat out inverse right here. So just plain hit that key We've got this enter. Oh, we get an error. And if we're convinced that we entered everything right, that's an indication that we've specialized in this. Inverse does not exist. Now, just to make certain that this process works, let's go back and look at number 6. 1. Second matrix. I think this 2 by 2, let's see. Yep, that 2 by 2 is not. Oh, how convenient. That 2 by 2 is number 12. And we're claiming this is 12's inverse. So let's get that all in one viewing window. And let's check this out. I'm going to go second matrix D and inverse x negative 1. And sure enough, there it is, 7, negative 2, negative 3, 1. Now, one thing to point out, you may notice some things about these inverses of 2 by 2s. There's some similarities. The 4 and 2 switch, the negative sign switches, the 3s either stayed the same or maybe they flip-flopped sides there, but all those numbers are still present, just with some negatives. And then in number 12, we go through this process and we realize, well, the 7 and 1 switched, the 3 and the 2 stayed the same, but their signs switched. Maybe there's some patterns here. I'm just going to tell you, do not bank on it. The patterns exist because of this. And notice if AD minus BC is 1, we get 1 over 1. And the inverse function, you switch the D and the A, you switch the signs on the C and the B. But if this becomes negative 1, something different happens. And if this doesn't become, let's say this becomes 7, now all of these would be on 7s. So you're going to see this kind of thing pop up a lot. And you may be tempted to think that, hey, I can just pattern my way out of this. That's heading you down a bad highway there. So that's what I'm going to stop today. We've got a fair amount of meat left in this section, but that's the mechanics that drives it. And stay tuned. Let me pull up the assignment here for you. I would expect at this point you should be comfortable getting through 23 at minimum. Good luck. Let me know what I can help you with. And enjoy matrix goodness.